Right, hello again everyone. So you know who I am because I've been comparing away. So my name is Ozsvald, I'm co-chair of the conference, and I'm going to be talking now on shipping data science products. The background of this is rather than looking at individual techniques and technologies and machine learning approaches, here I'm trying to look at the bigger picture. How do we as practicing data scientists successfully deliver working products for clients? And I'm looking at the business side of this, not the academic side of this, although there are a couple of slides touching on academic reproducibility later on in the talk. So who am I? So I've been doing industrialized data science for 15 or so years. I started after my master's degree, late 90s, in an AI research company, a French-British company. 5 years there as a senior programmer, working on the productionization of alpha to beta products using AI and getting them into big corporates. And then after that, I left there and started my own consultancy, and that's grown into Model Insight, which I run with my partner, Chris, who's around here somewhere this weekend. And we work on industrialized data science products, somewhere around natural language processing, machine learning as a particular specialism. And so for 10 years, I've been shipping things that work for clients. On a couple of occasions, I've nearly shipped things and they haven't worked and we've killed the project, and there's been some important lessons behind that. But generally, the reason why it's worked for over a decade is because the products work. That means that I've learned a lot of lessons about how to make things work successfully, how to de-risk things, how to position things correctly at the beginning so you get them all the way through to success. And this kind of touches upon what Meta was talking about this morning, with a process in place where model building is a part of the process, but there are many other things around it. I'm also an O'Reilly author. I've plugged the book enough, I think, and I've been growing this, or part of the group growing this PyData meetup and conference series over the last year. So thank you very much for coming. I'm really excited that we've grown so much in the space of a year. So one of the interesting questions, I think, is simply which kind of projects succeed in the first place? So data science means many things to many people. The definition that I tend to use is that a data scientist is a statistician who knows more engineering than their colleagues, and a programmer who knows more stats than their colleagues. Because it just means that I'm more on the engineering side. I've got colleagues who are more on the machine learning and stats side. We sit in some kind of continuum. So no one person knows everything. Of course, it's a huge field, but data science is described as being this wonderful, massive thing that solves all problems using data and big data. And they're silly terms. They're not really very descriptive. We need, I think we need ways of beginning to talk about the kind of projects that work so that we can identify projects. And this shortlist is made by looking at things I've worked on in the last 10 years that have worked, and also spotting the projects that haven't worked and then taking them out the list. So the things that I think work particularly well, 4 basic areas, and I'm happy to take additions if you reckon I've missed something. Explaining data, so some kind of visualization. That's the obvious start point for a lot of projects. Underrated by anybody who likes doing interesting stuff, but the ability, as Kieran said yesterday in his visualization talk, the ability to communicate to the hominid visual cortex, quoting Kieran, is incredibly powerful. And if you're presenting results to anyone with money, pretty pictures do the right job. So we don't need clever models, we need pretty pictures that explain what's going on. So the first point for me was underrated for a long time. It took me a long time to realize that I should just make nice diagrams. Automating repetitive and slow processes. So there's an awful lot of value here. Most of us spend an awful lot of our time. Our keynote yesterday, Helena, spent many months doing manual curation of optical character recognized data from scanned PDFs to make Excel spreadsheets so that she could draw some graphs explaining how money was moving with lobbying firms, I think it was. But the majority of that task was simply doing the data scanning and extraction. And automating that's incredibly important. And then augmenting data, so enriching search results or making new features for machine learning. This gets you to the next stage where you can do really interesting stuff. And it's typically what we think about with data science, but those first 2 steps are very important. And then finally, predicting the future. It's all about the machine learning. Well, it's kind of about the machine learning because that's just another step in the process. And if you think I've missed anything off, then I'd be happy to hear feedback. So I'll talk about this in the context of several examples. So I've been working with a company called Elevate Direct for the last year and a half, and I'll use them for a couple of my examples. So Elevate are trying to automate contract recruitment. They're contract recruiters who realised that at some point someone would automate the industry and take humans out of most of the loop, so they decided to do it to themselves so they could get the exit. So they hired me and my group as the internal data scientists, and then we are automating all that hard, messy stuff with the text. So you upload your CV, you don't do anything in the site, you just upload your CV, we recognise it, pull out all of your messy text tokens and the poorly described companies where you write, one of you writes Royal Bank of Scotland, one of you writes RBS, one of you writes RBOS, and we know that that's the Royal Bank of Scotland. We normalise all of that and the skills, and then we can match your CV to jobs that are in the system and start to meld them together. And the kind of tools that I've been using there, so MySQL, Mongo, Elasticsearch, and then Pandas, Scikit-learn, and the rest. And so that's a year and a half of shipping working services into this system. So that should give you a bit of context that I can work around. So a slide on visualizing, first of all. My best observation so far in 10 years is that most data isn't that interesting. And even if you've got interesting data, it might look interesting to you as wearing a scientific hat, but from the business point of view, it could well not be interesting too. So probably what you need is some kind of detective person, so that's the scientist, and also the human curator, so that'll be an internal business person, maybe a CTO, maybe a CEO, someone who knows how to drive the process. If you have those two people, or a CTO that knows both of those roles and is happy to put the time into this, and they're good enough to pull out the dirty data and transform it and clean it up and do whatever's necessary to present it, then you have a very powerful pipeline to explain what you've got in your data stores, or also to figure out what's missing in your data stores and figure out what kind of data you have to collect to tell the right stories. I know that Seaborn, that's bottom left, has been mentioned. If you're not using Seaborn but you use Matplotlib, definitely look at Seaborn. It gives us many more powerful visualizations in one line, so much less faffing around writing lots of loops and trying to make Matplotlib look like it's doing the right job. It just makes things a lot easier. Bokeh was talked on Friday, that's getting quite powerful. And HDF Compass, anyone using, if any of you are using HDF5, so large matrix data stores, gigabytes or terabytes of matrix data in flat files with HDF5 with great Python support. HDF Compass is a visualizer on top, so rather than pulling it out, say, into Pandas and then drawing graphics, you can do that maybe with HDF Compass. So we've got a nice set of tools in Tableau commercially to visualize our data. Extracting data from binary files is not often considered to be a worthy task. It's something that I've spent a majority of my time in the last 10 years doing, because getting the raw data out is absolutely necessary so that you can begin to do anything interesting with any of the projects you've got. For example, with the Elevate project, the last year and a half, the first 9 months, I spent basically cleaning up and normalizing data, making systems that would automatically clean up this data. So if I've got hundreds of thousands of CVs with lots of different spellings of the Royal Bank of Scotland and 20,000 other companies and 50,000 skills and all of their variants in domains like IT that I understand and oil and gas that I don't understand, or medical, which I really don't understand, how do we automatically clean that all up, denormalize it, get canonical lists of companies and skills as my targets that I can work towards, deal with all the weird text encodings? It takes a lot of time. This is someone coming into this, particularly if people coming out of academia are often surprised to discover that data sets aren't beautiful in industry. How many academics are in the room? Probably not. Okay, a couple, right. Okay, so in case you haven't spotted it yet, industrial data sets are rubbish normally and need a lot of work to clean them up. So rather than doing this kind of work by hand, you don't want to be writing all of your rules by hand, or as Helena was doing, cleaning up OCR output by hand, we want to automate it. Textract, that's a nice Python wrapper around a number of tools, which you can probably barely read on the right-hand side. That was a screenshot of their doc page. With Textract, you can do OCR, you can extract HTML, you can do speech recognition, you can extract from Word documents, PDFs and all sorts. Often it extracts that binary data into some text representation that's not particularly brilliant. It doesn't mark things up for you, so you have to figure out where in that text of a person's CV are company names and dates and experience blocks and lists of references and email addresses. Nothing does that for you. There are specialized tools like Sovereign that begin to do that. They're commercial tools. There's There is one open source project that will read PDFs of academic research papers and try to mark them up and then break out the various sections as a human would and do that automatically. I forget the name of it. Anyone know what I'm talking about offhand? Anyone doing research on academic papers, there's certainly an open source tool for this that's trained with an ML backend, which is quite nice. Turn it in, that's not what I had in mind.
Is it content mine?
Surmine, yes. I think content mine is Surmine. Surmine may be the contraction. So Surmine is something to C-R-M-I-N-E. Worth searching for if you're doing that kind of work. But this takes a lot of time. And as a tiny example of something I worked on a couple of years ago with Kieran, who spoke yesterday, doing optical character recognition on phones with photographs of botanical garden labels. So this was in the Royal Botanic Gardens queue, taking photographs of these labels using OCR and text cleanup. This is all in Python using Textract and Scikit-Image and a few other tools, and OpenCV, putting out as many characters as possible, not terribly cleanly, but then using Elasticsearch to match them to corresponding Wikipedia articles. So essentially you use the plant label as a kind of a QR code without applying QR codes into reality, and then you can recognize tens of thousands of different plant labels automatically. And then when I was living in Chile for a little bit, we tried this in the Botanic Gardens in Chile. They have a Latinified South American variant of spellings, but it still worked, and so I was really happy with that. No need to change the way of processing the text because it's still a human-readable text, so the OCR process worked just as well. Once you've extracted data, you have to start augmenting it to either generate features for machine learning, say, or to present it for visualization, or putting it into search engines. So we've got lots of tools that enable us to do that. DataSift has been mentioned already, so they're a provider of lots of social data. If you want to get lots of Facebook messages and then start to analyze those, you just buy them through DataSift, so that's great. And Alchemy API, further down, they let you do pretty good sentiment analysis and named entity recognition. It's one of the best providers that I've evaluated. So if you want to find names of people or places or products, then Alchemy is very good for that. It's got a US bias. It's not terribly great in Europe, and it's not great for many other languages apart from American English. But and there are other providers coming along. You can, of course, use lower-level tools like NLTK to write your own and build these up, but that becomes quite an involved process, it turns out. One interesting trend in the last couple of years is the rise of open data and connected open data datasets. So a few years ago, the Wikipedia dataset made available through DBpedia, kind of a triple markup of facts from Wikipedia pages, was pretty weak and it had lots of errors in it. Now, I base a bunch of the machine learning work that I do with Elevate off of the open data that comes out of Wikipedia. So definitely have a look around at different open data sets. There are thousands of sets now which all have links into each other, so you can pull data from one source like Wikipedia and link it out to associated sets and build up a free great big corpus of things for learning against or do similarity matching against. Here's a side project I have right now, and I've got two good reasons for mentioning this. So my wife is allergic to the air. She claims she is allergic to the very air that she breathes, and has been for all of her life, so she sneezes a lot. We'd like to diagnose what is causing this. So she's an iPhone developer, just recently joined Mozilla. So on the left, she's written an app for herself where she can record when she has allergic symptoms. So she's sneezing, or she's interacted with a cat or a dog, or smelled a flower, or she's taken loratadine, so an antihistamine. So we can record the events there. On the right, I'm building up a model using mostly pandas, just taking that raw data and putting it onto a timeline. The black bar is a poor representation, I know. The black bars are 24-hour periods. Those blue dots, that thick line of blue dots, that's her sneezes. So she sneezes a lot. And then the question is, what drives the sneezing? Can I use machine learning to start to look into this? I've got a note at the bottom there that I'm pulling in her diet data from MyFitnessPal, so she logs the food that she eats. We're pretty sure that alcohol the night before, which does affect histamine levels, has a knock-on effect the next day with her propensity to sneeze. Pollen in the air, that's reported on the BBC News website, and the Met Office and the Benadryl site, but there's no clean API, so I'll be scraping that shortly. And then pollution data, that was covered in yesterday's Open London Air talk. So there I'm taking PM10 and PM2.5 particulate reports around London and then modelling pollution in the air. And this all gets merged into pandas due to the time series merging to give me a really rich data set which I can do my machine learning off. So this is, This is fun for two reasons. One, I'm hoping some of you might have done this kind of work before and can give me some feedback on the projects you've worked on, time series data, predictions, and the medical area in general. And secondly, I get to do science on my wife, so this is kind of good fun. And I get to do it because she can write an app, and I can use pandas, and then I can draw in rich data sources, partly open data, partly scraped, partly data we're deriving ourselves, and then with a fully open source tool stack, we're able to generate a machine, well, I'm beginning to generate a machine learned model around this to understand her allergies. And we've got several friends of hers who have allergies as well using the app, gathering their data sets. So here we're looking at an approach to personalised medicine, not via some big study, but just because I'm kind of curious about it. I'd like to see her not sneeze so much. I'm not sure where this goes. I hope it actually works. I think it's not a stupid approach. But it's kind of fun that it's so easy to do with the tooling that's available to us. So, talking of this tooling, we had a tutorial on Friday about the PyMC package. I'm pretty sure everyone here knows about scikit-learn. It is the main machine learning tool in Python, and it's a very large project with a lot of contributors. Has anyone in here contributed to scikit-learn? Somebody else, surely. Okay, in that case then, that text in black, the simplest thing you can do if you want to contribute to any open source project and you have not the time or the confidence or the inclination to contribute code or docs, is to cite those projects. So simply either cite that you use them, or even better, send them a testimonial saying that you use their project. Because they use that to get funding from academic bodies, from research councils, and from non-focus and other groups. So if you simply tell them that you use their project, you put your company name against them, you help them. That's your easiest contribution to open source libraries that you can make. So I urge you, please, to at least try and do that. Scikit-learn, there's been a wrapper released recently, Sparkit-learn, which wraps up the PySpark interface. So rather than having your scikit-learn data modeled on your laptop and then re-implementing using PySpark on a slightly different interface, instead with Sparkit-learn on Python 2 and Python 3, you can drive the Spark distributed machine learning toolkit, so that's really nice. Roloff just earlier spoke about Theano and Caffe and the deep learning research. So Python's very popular for deep learning research, partly because it had great drivers for GPUs, so people could build new tools on top of the GPU drivers and just put that whole stack together. This is part of why Python wins in general, I think, as a glue language. We have so many tools that glue so many different bits of the stack together. It's easy to start building new tools when new domains come along. Here's a question for you, and I'm after your feedback on this. It strikes me that one of the least efficient areas of my time at the moment is debugging the models that I build. I have strategies for looking into classification tasks where I've got my main strength, particularly around text classification. So that's binary sparse input vectors for, say, a binary classification task. That's very different to a regression task, very different to image analysis. And yet I'm pretty sure that I go through a similar loop with my approaches to diagnostics, looking at the quality of a model and the actual outputs of a particular model and the outputs of a different model, trying to understand which features and which kind of internals in the model are affecting the quality of an output. And yet I do this by hand. I'm pretty sure most of us do this by hand. I'm pretty sure some of you have written either tools or processes to automate some of this, or to at least remove some of the vagary in your thinking. If nothing else, please come and tell me. I want to find out better ways of doing this, because it feels really silly that I'm making this up over 10 years as I go along, and I think we're all making this up. So there must be a better way to do this, and there must be some tooling we could produce. So I'm really keen to see if we can generate any new tooling around this. Anything that helps to simplify. Scikit-learn was a really not powerful library about 5 years ago. Everyone kind of laughed at it. So yet another machine learning library, who really cares about it? Now it's a big tool, but it started with just a couple of clean implementations of useful algorithms. So what about doing the same for visualizing the quality of a model and trying to pull out its internals? We don't get any data diagnostics either, so logistic regression. If you pass in two features, one with huge scaling and one with small scaling, probably the second feature gets represented poorly due to the error surfaces that come out. A beginner may not know this. An experienced person will know this, but may not realize their data is laid out that way. They've just tried some new data, they've just downloaded some, put it into a model, they get an output, they're happy enough. What about a decorator we can add to our scikit-learn models that just says, oh, the data should be normalized within range 0 and 1. It should be Gaussian. These, we don't expect any strong correlations between our features, just some way of marking up how we should describe our data to think about it at a slightly higher level. I don't think I'm crazy for suggesting this. Maybe some of you have thoughts as to why this is a bad idea or have done this, so I'd love your feedback. So yeah, your hard-won knowledge, please. Help me make new debug tools. So it's not terrible. I mean, on Friday, we had a nice tutorial from Chichun and Elena from Cambridge talking about representing the decision boundaries, say, for 2 features. We can go to 3 features. We can't really go to 4 features. We can't go to 1,000 features, of course. But if you've got 2 dominant features, we can begin to pull this apart, perhaps. So we get something out. And then the image in the background, say with a decision tree or an ensemble of decision trees, like a random forest, you can pull apart 5, 10, 20 features and begin to look at them. And then I stole Rolof's image from the last talk, beginning to look at diagnosing deep training networks. He's got some nice slides looking at what the deep belief networks are doing at different areas and then how their training performance varies and strategies for combating poor fitting. So there's clearly thinking about this, but I haven't found a book talking about this. So yeah, any of your knowledge, please bring it forth. I want to hear it. So right, now we've looked at ways to build up successful projects and this serious problem that I think we have with diagnosing how our machine learned systems aren't working. Now let's look at pushing it out to production. So delivery, apply the KISS principle and just keep it simple, and that's the biggest thing. When I was speaking with the academics, I was teaching PhDs a couple of weeks ago in Denmark. I was invited to speak to faculty, and we got to talk about reproducibility, which I'll cover in a minute. I thought it was important to make the point that in industry, we're typically, not if you're not in a benchmark, you're not publishing the best result. You want a good enough result to solve your business problem so you can effectively move forward because you've got a million problems to solve. So debuggability at 3 a.m. is one of the keys, I think. The more complex the model, the less likely the CTO is to understand what goes wrong when the system turns off. So you don't want anything to be overly complex. I like Watson Watt's idea of the cult of the imperfect. So Watson Watt was one of the developers of radar during World War II, and he'd say that the best system, we're not going to have that, it's never going to turn up. The second best system, we could have that, but it will take too long. Third best system, we're going to get there, we'll have that one. And this idea of just, it's good enough, we'll just work with that. If that was good enough to develop radar in World War II, that's good enough for me delivering systems to my clients, unless we're doing a benchmark, but that's a less likely eventuality for a client. And so that last point, dumb models and clean data beat most other combinations. Definitely more data can help in the right kind of scenario. And dirty data, if you've got lots of it, maybe you can get quite a long way with that. But in my experience, feature engineering and lots of data cleanup so that you're putting good stuff into a model in the first place. Probably a dumb model like logistic regression works pretty damn well, and it's easy to diagnose. So always strive for simplicity. Put more time in to make it as simple as possible afterwards. And then there are various ways to kill a project. So I interviewed a number of CTOs over the last year to find out what the biggest reasons they'd seen for a project dying around them, for a data science project dying. The number one reason was simply missing data. So either lots of data, but it was the wrong stuff, so they'd logged the wrong stuff, or too many gaps, or they gathered almost all of the right data, but were missing a key feature. But for whatever reason, there wasn't the right data available. And the simple advice that comes out of that is just log everything. Storage is fairly cheap. If you're logging a fraction of a second sensor data, then maybe there's a large storage cost. Maybe that's not quite the right strategy. But for most companies, they don't have a big data problem. So storing gigabytes worth of data, it just fits on a hard drive. It's really easy. So just log all the pertinent stuff. And a company like Segment.io will take all of your different feeds of data in, they look after it, and they can join it to external data sources for you from other companies. So that can simplify a whole part of that data storage and analysis pipeline, or just put it into Mongo. I mean, I don't care where it goes, but just don't lose the damn data. If you're storing lots of data, it will go wrong. You will miss things, there will be lies in there, processes will log the wrong stuff, and if you're dealing with past data, so data someone else has given you, it will contain lies. It will not be as clean as anyone thinks it is. So you need data quality reports. This is one of my biggest time sinks in the last year and a half, and it's probably been one of my biggest time sinks over 10 years. So inheriting other data and logging new data, and then it's the wrong stuff. So be very clear that you need to have some kind of reporting in there to get high quality data out. And it's definitely worth noting that R&D is not the same as an engineering process. If you're the sole researcher in an engineering group, and the engineering group hasn't had a PhD researcher in there, then all of a sudden the working requirement changes a lot. It's totally okay to push back and just say, no, hang on, this is not an agile engineering process where I know what I'm going to deliver, how long it might take in some kind of estimation game, and then I'm going to deliver it. This is an R&D process. This will be iterative. There will be failure. We're going to learn from the failure, and this is part of the process. It's totally okay. There's a new tool, DSAD. I think that's Data Scientists Against Dirty Data. One guy taking an R tool and moving it into the Python world. So I just mentioned that as part of your missing and poor quality data. You use decorators for data frame analysis to put some constraints on your data frame. This feels like a good idea. Maybe this is worth extending. So for deployment, I've used the IPython notebook for internal deployment. I'm guessing some of you may not have seen the interactive feature. So that interact function, you give it a function, you give it some limits on a variable. So that variable f takes 16 to 18 in 0.1 increments. It gives you a slider bar or a drop-down or a text box or a button. And then as you slide around in your IPython notebook, it will update the plots that you're generating. That's supremely useful for demonstrating things internally to colleagues, particularly giving them a mental model as to how you change some variables and the outputs change. That's just really good for getting a deep model inside your head as to how some kind of complex process works. But you can't put that on the web because that exposes your entire Python interpreter in whatever environment it's running to the web. So you could just type os.system rm star. That would be a bad thing. So don't deploy IPython notebook models onto the web. We'll look at another tool in a second. I guess that'll do for that. The tool that you might want to use is Spire. So with Spire, it's a bit like our Shiny that was mentioned in a talk earlier. You can use pandas data frames and tabs and buttons and sliders and then mount your models on a web service that only exposes a thin connection. So it's a very secure way to put models out there in a prototype way. Personally, I use Flask in a microservice. So Flask is a RESTful API tool. It's like a lightweight Django. So in a couple of lines, I can write to get and put requests, which let me take requests and take data, and then query my NumPy models or my SciPy models or my scikit-learn models, and then return some JSON as a result. So it's a really powerful way of packaging up some of these tools. And I think Docker, which gets us towards a reproducible environment, I could run a Docker machine here with a virtual box inside it, and I can deploy that to Amazon EC2 or to Azure or to a colleague's machine, and I get exactly the same environment to run my code in a reproducible way. I think that's a way of the future. It's not solid right now, but we're experimenting on that in Elevate. That's going to be an interesting tool in the next 6 months. With Flask, you can do Swagger documentation, so a couple of decorators on your Flask model, and it will expose a web page which has all of your API endpoints documented, and a text entry box. You can copy in your query, the same query you'd send from your other language over the wire to the microservice, hit the try it out button, and it will query your API, and then take the JSON response and display it below so you can diagnose it. This means you can put examples in the web page, which is your API, it's your actual API. It's not separate documentation, it's just the API. So that's a very nice, powerful way to document your running models. So when I spoke with the faculty in Denmark a couple of weeks ago, we had a quick chat about reproducibility. I was curious about the rise in people noticing that many research studies can't be reproduced. That's bad, right? That's a waste of money and a waste of people thinking they found something significant that maybe is not significant. I suspect that at some point, someone is going to say, if only there was a domain where every time you ran this thing, it ran exactly the same. I bet they figured out how this reproducibility malarkey works. And someone's going to go, computer science, right? These computers do the same thing. It runs the same every time. Let's go to the computer scientists and the data scientists who are there and figure out how they have these fully reproducible systems. And then people are going to come to us and we're going to go, yeah, it kind of works some of the time on my machine. And it's not quite the same as having a fully deployed reproducible system that runs anywhere, right? But we are solving this problem. Many academics aren't worrying about this yet, but nature is beginning to require reproducible work before they publish articles. So it's going to become bigger in that domain, and it's going to become more required in our domain as well, particularly publishing, say, scikit-learn. You can fully reproduce all of that test suite on any machine. That's a nice example of reproducibility in the face of randomness. So there are ways of doing this, but I think this will become a more important thing as we go. And the IPython notebook was then featured in Nature as a way of using reproducible computing. So notebooks and data mounted onto an EC2 instance. And then that little box down the bottom there, so that's the article that describes to regular readers of Nature why you should use Python for reproducible science. That was quite a strong statement. So I'm going to wrap up with a couple of slides. Python deployment. If you're not making modules in your code already, you should be making modules. So that means you can just do a Python setup.py install on the module and have it run on your machine or your EC2 machine or your colleague's machine. So you can version it and you can document it and distribute it. If you don't know about Python setup.py develop, is Tony in the room? Right, Tony, Tony, yes. Tony told me 2 years ago about Python setup.py develop. It means you haven't got to install it inside your site packages. Instead, in your site packages, you get a symlink back to your development directory. So it looks like a real package, and you can then package it up and distribute it, but you develop it just locally like you're developing it anyway. That's supremely useful. You want unit tests and coverage. If you haven't done this kind of thing before, I've got a template. So on my GitHub and Ozsvald Python template with config, there's a configuration system in there, unit tests in a module format with some documentation and logging set up for standard output. So if you want a template to work off, go and borrow that. And if you want to look more into this kind of thing, I'd suggest looking at the 12-factor app. It's a nice write-up by another company, I think to do with Heroku, looking at ways of producing reproducible engineered systems. And Kieran's book that I've noted there. So in Kieran's book, he's talking about publishing your web service, your JSON-providing web service for visualization on the web. So he has a chapter covering some of this kind of deployment scenario. So he's still writing that book, but it's worth keeping an eye on that in the future. I'm not going to cover all of these. For anyone coming into the industry anew, you might think that we have lots of standards to make things easy. Some things are never standard. MySQL has full Unicode support, except that by default it's 3-byte, not 4-byte, so you can't get most of the funny characters into it. That's ridiculous. You discover that when you have question marks in all of your data. That's very painful, because then you have to just delete it and start again. There is a UTF-8 4-byte representation. You have to enable that yourself when you've discovered it after the fact. JavaScript months are 0 base, not 1 base, like in most other languages, so you have to -1. Date times, everyone thinks they've spotted a new way to represent the date time, so we have n+1 date time representations. Just use ISO 8601, fully qualified long string, or seconds since some well-known epoch. Note that there are about 8 epochs out there, so if I take the data from my wife's iPhone, Apple use 2001 as their epoch, not the Unix 1970 epoch. CP1252 encoded text is very common on Windows platforms. Excel by default will try very hard to only give you Windows encoding, not UTF-8. So that munges up a bunch of your characters. That's a pain. MongoDB times out by default, which is really unhelpful. No timeout cursor, true. That's a useful switch to know. So it's a bunch of stuff that you will discover is broken. These things will always be broken. Stack Overflow is your friend here. Generally, I suggest avoiding big data. If you've got big data, if you've got petabytes of data and you want resiliency or redundancy, or you just genuinely have a huge amount of data to query, fine, you've got a big data problem. Most people have a problem that may fit on a hard drive but not in their RAM, and they begin to think maybe this is big data. It's not. It may be medium data, it fits on a hard drive. Maybe it fits on 2 hard drives. You probably don't need a cluster. A cluster probably means you get really excited for a month and then you employ somebody else to sit by you and run the damn thing. This is inefficient and a waste of time. If you write multi-processing code, say, on a laptop with 4 cores, and then you go and rent a 32-core machine on Amazon with 250 gigabytes of RAM, it'll cost you $3 an hour. It's really cheap. So you can just make your model locally with a subset of your data, upload the real big data into Amazon EC2, rent a big machine, run exactly the same code in parallel. So these here are random forest models in scikit-learn, fully exploiting a large machine. And then you can get your completed model, save it as a pickle, download it, and then you've got a finished model trained on a very large data set without the requirement for having a cluster and a person to run a cluster. And there's a relatively new project, X-Ray and Dask, that I mentioned at the bottom there. That's for out-of-core labeled arrays, so data that's too big to fit in RAM but fits on a hard drive. So that's a medium data packager that lets you run through your data without having to go, say, to a Spark solution. So I'm interested in hearing your dirty data stories. I'm beginning to automate some of this. I'm certainly collecting tools that let me automate this because I'm so bored of having to fix all this data myself. It's such a waste of my time. I don't want to do it anymore. So tell me what bothers you about your data, because I'm collecting stories, I want use cases, and I'm beginning to write tools that fix some of these things. Definitely keep it simple. Just strive for simplicity. Separately, I'm just going to plug my PyData meetup again. Come and share your war stories and your projects at the monthly meetup we run in London. So 1,600 people, it's a huge user group. And on that note, that slightly silly quote there, I'm not trying to be up my own bottom here. Part of the reason why I build the group is because it's way easier to solve my problems if I can go into a room with 200 people, find the 3 people who've solved this thing before and just ask them how I do it. Right, that makes my life easy. So there's a hell of a benefit towards coming to one of these meetups and just being part of the community, because it makes your life easier. You get to get past the boring questions far quicker and then get on to the more interesting stuff. So I definitely encourage you to come along. And on that note, we're a couple of minutes, in fact, lunch is almost starting. So I'm going to wrap up there, and I'm going to suggest that if you've got any questions, come and talk to me afterwards, because there's no queue for the food right now. Thank you very much.